Welcome to another session of the 2020 GovHack Virtual Conference. We are a festival of ideas using open government data to make our communities better places. GovHack is an international competition for people of all abilities who seek to make life better through open data. In just over 2 weeks' time, on the weekend of the 14th to 16th of August, thousands of people come together in what has become one of the world's largest open data competitions. We are hoping to deliver an interactive experience through YouTube. So if you're viewing the embedded video through the hackerspace, click on the YouTube logo to open the video in a new tab and join the conversation. This evening we'll hear from Craig Lawton, Internet of Things and Cloud Architect, speaking about open data with the Amazon Web Services Quicksight and Athena. We will also hear from Mark Seddon, AWS Solution Consultant, a fast way to build scalable mobile web apps. First up, we have Craig. Welcome, Craig.
Thanks, Matthew. It's great to be here today, and it's a really great conference to be a part of. And you may be asking, what's an IoT architect interested in open data for? It turns out that a lot of the value in IoT comes from the data collected from sensors and bringing that together into the cloud where you can perform analytics and look for insights on the data. So today we're going to have a little bit of a walkthrough. I'm going to demonstrate some of the services you can use to really quickly dive into structured and semi-structured and even unstructured data. I'm going to show you how I've grabbed an open data set from the open data portal for the City of Melbourne, how I uploaded it to Amazon S3, that's our simple storage service, how I crawled that data and then used the crawling and cataloging features of AWS Glue to make it referenceable and defined in the Hive metadata catalog. I used Amazon Athena then to query that data using ANSI compliant SQL querying, and then visualize that those queries in Amazon Quicksight, which allows you to use a BI tool, BI analytics to get really good and quick ad hoc insights into data. And then also I'll briefly talk about how you could include that in an application. So if we look at reports and ad hoc analysis, there are several services that are very commonly used across AWS and Amazon. So firstly, if we start at the bottom left there, we've got 3 S3 buckets, and a bucket is a place for storing objects, or files as other people like to call them. And you can see there that there's several files, several buckets, sorry, that can be used to transform the data. So this is a data lake construct where you can use event-driven architectures and event-driven compute functions to process your files as they arrive in a raw bucket into a transform bucket, allowing you to then use those processed data as the basis for insights and for your applications. Today, we're just going to use a single bucket just to demonstrate the concept. And then above we have ETL, and you can use AWS Glue to perform extract, transform, and loading of the data. We're going to use it today primarily for crawling the data and making sense of the structure of our sample data set from the City of Melbourne. And then you can see some of the services you can use to query that data. You have Amazon Redshift, which is our petabyte scale cloud-based data warehouse. But then you have Amazon Redshift Spectrum and Amazon Athena, which will allow you to query the data at rest in an S3 bucket without having to spin up any services or any databases, sorry, or EC2 instances or servers in the cloud. And then finally, as we move across to the right, we can see that we have Amazon Quicksight, which allows you to really quickly perform analytics on your cloud-based data sources. But you can also just as readily use any BI tools in your preferred tool set to analyze this data, because all of those querying engines, if you like, Redshift, Redshift Spectrum, and Amazon Athena, provide ODBC and JDBC interfaces, which allows you to connect your favorite tools to them. And today we're going to look at, as I said, the open data portal for the City of Melbourne. And we jumped in there. It's data.melbourne.vic.gov.au. And I exported the pedestrian counting data. And if I just jump across to the console, So if we have a look, this is the open data portal. Many government organisations have these portals, provide data that allow you to hack away. Connect into the census here, and this first one is the one that I used. I clicked in there, and then I just hit the export, and you can save it as a CSV file. I then uploaded it using the AWS console to an S3 bucket. I created a bucket here called CCL, my initials, Melbourne Head Counter, and that is the 260 meg file downloaded from the website. So what did we do next? So if I go back to the presentation, the next step, if you recall, was to use AWS Glue, and we're going to use this to catalog the data more than anything else, though we can also use it to do extract, transform, and loading of data into other databases and data stores. So the important thing to understand with the AWS Glue crawler is it can automatically discover the data and store a schema based on what the data looks like and make that searchable. If you're going to use the ETL functions, it also allows you to create code. It's all serverless, and it's built on open code and open source software under the hood. So these are the components of AWS Glue. It's very popular. It's part of all of our AWS-based data lake solutions. You have the data catalog, which is based on an Apache Hive metastore and does the automatic crawling of the data. You've got job authoring, which auto-generates code. So you can actually go straight into the console and see it in Python or Scala or Apache Spark and edit the code if you like, but you can create a lot of the jobs using the interface. And then it can execute those jobs, and you can do flexible scheduling in batch or micro batch and have it all monitored using CloudWatch. Here's another diagram that shows a little bit about how this could be built on if you were to build a data lake as part of your GovHack solutions. If you have a look at the left there, you've got data in many different sources: Amazon Relational Database Service, other databases on-premises, streaming data, that could be IoT data, and it comes into an S3 bucket, and then you can use Glue to extract, transform, and load that particular data. And then the next step is it goes to crawl the data and populate it in the catalog. Once that catalog's ready, you can query against it using a multitude of different services. We're going to use Athena and then Quicksight. And if we go into a little bit more detail on what the data catalog is, it's a unified metadata repository that you can use across all relational databases, either on AWS or on premises, and Redshift and S3. So metadata, it's the data about the data, if you like. That it provides then a single service for you to view into the data, and you can do things like classify and add business metadata, etc. But what are crawlers? So crawlers automatically build this data catalog and keep it in sync. So it scans the data. In this example, we've just got one file, CSV file, but could this be multiple different data sources in different locations? It extracts the metadata and statistics about it, and then adds the table definitions into the data catalog, and we'll see that in a sec. And so this allows you to discover data and extract the schema definitions and automate a lot of the work that you would typically have to do yourself. And also you can run these crawlers batch or on a schedule, so you can have them run effectively like a cron job. And it's serverless, and you only pay when the crawler runs. So we switch back to the console. We have a look at what Glue has done here. So in Glue, we've got the console here, and we're looking at the crawlers. I've got a few here, but this is the one that was created to crawl through the S3 data. And if we have a look here, it's been created. I've given it a name, and then it creates, as part of the crawling, what's known in Glue as a database, which is a database about the metadata. And you can see that it's scanning in the include path my S3 folder where I put that CSV file, so the S3 path. So we ran that, and after we ran that, it created this table in the database. We'll have a look at databases first. So you can see that's the database. Inside the database is a table. And you can see two tables there, but we'll just talk about the first one, which is the one that's produced by the crawler. We can click on that. We can see what it's discovered as part of this particular table, which is based on what was in the CSV file. And you can see it's identified the structure about the pedestrian counters from the City of Melbourne. And this was all able to be created very quickly, just by stepping through some of the blog posts and the how-tos and the documentation. So I'll get back to the presentation. So that's Glue. So Glue will crawl your data, identify the schema, catalog it, and put it in a table inside a database. And then you can use another service like Athena, which can perform SQL queries and do analysis of data directly from S3. And so, as I mentioned, it can query data-based S3-based data lake. You can use this for operational and application log type analysis. You can also, as I mentioned before, use all the popular BI tools you like because it comes with a JDBC and ODBC connection. So it really allows you to quickly get into your data without having to think about setting up databases, deploying infrastructure. Allows you to get into querying the data really quickly. And it's serverless. You'll find that many of our higher order services at AWS take care of a lot of the undifferentiated heavy lifting. So you don't need to think about infrastructure or administration. You don't have to think about spinning anything up. It's just ready to go. And then the underlying service itself is upgraded transparent to our customers. When you run queries against the data that's in S3 and been cataloged by Glue, you can use standard ANSI SQL. So you can do things like complex joined, nested queries, etc., and complex data types. And you can also partition the data as well. And under the covers, it's using a couple of well-known technologies. So it's using Presto, which was originally developed by Facebook, I believe, and open sourced to perform the in-memory distributed query engine across all of that data. And also the data dictionary is stored in Apache Hive. So that's how it stores all of that, which is automatically scaled and managed as part of the service, so you don't need to see it. And Athena is very cost effective, so it's really great for these ad hoc queries and when you're trying to get into the data quickly and you don't want to waste time on setting up a complex infrastructure. You pay per query, $5 per terabyte scanned, and so if it's a gigabyte, well, it's about a 1,000th of $5, and it gives you an idea it's quite inexpensive to query this data. So let's have a look at Athena. So we go to Athena. Over here on the left, we've got the source. That's the AWS data catalog. That's our catalog, and that's the default catalog for my account. We also have this database. Now, if you remember when I did the crawling of the data, I had to specify database name. That's what's there. And you can see it's discovered one table under there. This is the table that's based on the CSV file. And we can do a little preview there and we can have a look at it. So I'll just scale it up so you can see. And you can see it's a lot of data there with IDs, date, timestamps, months, the whole thing's in there. And you can also run queries. So if I go to, I think it was this one. Yes, so this is a query I created earlier, and it's basically SQL. So it's looking through that data that you just saw a preview on, finding the ID, the date, timestamp, sensor ID, and a bunch of other things. It's looking for where the sensor name is Australia on Collins, and it's looking for anything in the month of May in 2014. So we should be able to run that. And the query took 1.32 seconds, and you can see the results down there. Now, the other thing with Athena is you have the ability to save queries, so you can create views. So you can create a view there. create a view from the data. Now, here's one I created earlier. This is a view, and if you might remember when we were looking at the tables in Glue, there was this one called columns. We have a look, preview, we can see what's in there. It's basically a SQL query, which is finding a subset of the data for 3 different sensors, 3 different locations, and during a particular time period. So I think from memory, see if I can find it in, I think it was, I thought it was 12, maybe it was 9, 10, there it is, finally found it. So this is the query. I created this view, which then got populated into another table. A little bit different to the other query in that it's got this create or replace view at the top. The view itself, if we have a look at the properties, show edit query. So this is the best way to do it. Here it is. You can see that I extracted and modified the timestamp and the date, and it's important to do that in Athena to make sure your date and time format is going to be understood by the querying by the BI tool. So what we've done there in this date parse is take a substring of the date time field, and then we've converted it into a date format using these format strings. The other thing is I've looked for a sensor ID less than 4, so sensor ID 1, 2, and 3, and then that has created the output. So we'll I'll run that query again, so just it's fresh of mind. We do a preview. You can go through that data, and you can see this is the kind of data that we're extracting with this query, and this is the one we're going to visualize in Quicksight next. So why Amazon Quicksight? Why Amazon Quicksight? Well, firstly, it's cloud native, so there's no services to deploy. You can just get started very quickly. It provides very predictable, fast in performance. It's really well integrated with all our AWS services. So if you're primarily based in the cloud, then this is a great tool for really getting into your cloud-based data sets really quickly. It's got some features called ML Insights, which provide written word, context relevant insights based on the data. It's securely available in 10 regions and compliant with a lot of security attestation and compliance regimes. It's insights for everyone, so it's you only pay for usage, and it's really quite cost effective, at least compared to a lot of other BI tools. And it's very easy to deploy and maintain. And here's a couple of use cases. I won't go too much into the one on the right because I've already described that's what we're doing. We're loading some data from S3 and using Athena to develop a query and Quicksight to do a visualization. But if you look on the left there, you can also use Quicksight to pull in data from different data sources as well. So it can pull in data from Redshift, EMR, RDS, a whole bunch of different data sources. And under the hood, there's this thing called Spice, which is allows, it does a lot of pre-caching of queries to make your query results super fast. And as you don't need to think about it, under the hood, we are constantly scaling it and making sure that it provides you with millisecond latency and that it is entirely reliable. And that if there are any underlying infrastructure issues, there are zero impact to you. And once you've created these dashboards, you can create dashboards and share them with readers as they're understood. So you can create these dashboards that are for management or for an operator, for example, that make it very easy for you to share these to other people in your business who might not want or need to know about AWS and how to configure it under the hood. And you can also do these embedded dashboards. So you can create a dashboard, you can then configure permission and generate a signed URL and then embed that URL into an application, which is a very interesting application of analytics. So let's jump into Quicksight. I'll show what we've created previously. Skip across. So, first of all, I better get Quicksight up. Glad I'm running a bit ahead of time. I must have closed the tab. So we'll jump across to Quicksight. It's just opening up now. And we can see that it's, when it starts, just get rid of this. We can see that these are all the analyses I've used previously. Now, if you wanted to analyze some data, you can click over here on Manage Data. This sets up your connections to your data sources inside Quicksight. You can say, let's give me a new data set. And then you can connect to all these different services. So as you can see, S3, Athena, RDS, Redshift, a whole bunch of AWS-based services, but also Salesforce. Also these open source data engines like Postgres and MariaDB, and other tools, data analytics tools like Presto and Spark, for example. And of course, one of my favorites down there, IoT analytics. Now, if we look, I've already added one for Athena because that's what we're connected to in this instance, but just to show you what happens in here, you give the data source a name, test, for example, and then when you go through, you can choose which Athena table you'd like to connect to. Sorry, this is the AWS Glue table behind Athena, so you can connect to that one. We won't do that now. The database and then the tables you can connect to because I've already done one earlier. So we'll get out of here. If we go back to the visualize page, you can see I've already set up a visualization for the pedestrian data here. So we'll load this in and you can see here it's just rendering now. This is the graph of the 3 sensors that I got from my saved query plotted on a line graph. We go back here to Athena, we can see this is the data here from this particular view that we created from that query, populated. It's for the month of May for 3 sensors. So it's a nice, simple graph to understand. Now, if we wanted to create show you how this is created from scratch, we can create a new sheet just to make it easy to show on the screen here. And then you can autograph, so you can just drag the fields here that are from that particular query. As you can see there, the ones that line up with these. I can just drag them on and it can autograph, or I can choose. So I might choose to do another line graph. I'll just close this down up here so it's got a bit more space. And then you've got these field wells. So on the x-axis along the bottom, we've got S date, and this was the date that we formatted correctly so that it'd be understood. And then for the value, which is our y-axis, we want to know the hourly count. So that's how many people have been walking past every hour. Now, unfortunately, that's auto chosen that as a count aggregate. We want to have the sum so we can see. And then we can see, and this is for one of the sensors. So we can also add in the color here our sensor ID or our sensor name so that we can see these multiple graphs. And I like sensor name because it's a bit different to the other graph. You can see it's seeing sensor 1, 2, 3. You can see over here the location. So it gives you an idea. And you can see that it's quite correlated, which is quite interesting for the dates we have in May, that the people were moving quite consistently through the city, and the peaks and troughs lined up pretty well with each other. So that is where my little demo finished. I hope you have a good understanding of how you can quickly grab open data and use tools and services like Amazon S3, AWS Glue, Amazon Athena, and Amazon Quicksight to quickly get insights and visualizations into government data that you can then embed into your applications. Now, I'm 5 minutes early, I believe, so if there are any questions, I'm open to taking them on the call.
Thank you, Craig, for the introduction to the demos of the AWS tools that hackers can use on the GovHack competition weekend. It was great to see that demo of crawling and querying and visualizing the Melbourne pedestrian counters for their open data sets. I love the idea that you had there of combining multiple data sets and using IoT sensors, and potentially even hackers could be adding their own IoT sensors into this as well, to create, I suppose, a more broad data set of their own, and then visualizing it as well and demonstrating that was great to see. So I'll just see if we've got any questions on YouTube, and I can ask you through here.
Yeah, well, while you're looking, yeah, I've used just a simple S3 bucket, but if you're going to build a data lake to do a bit more processing or a bit more security or governance, or you wanted to import a range of different data sets, we have our lake formation service, which allows you to simplify a lot of the orchestration and abstraction of the underlying services and security and governance, so you can get started really quickly. We also have an open source version of our data lake called the Accelerated Data Lake, which people can Google for and find on GitHub, which comes with all the cloud formation templates, which can build that environment, and it uses some other tools to automate the workflows, including step functions, a few other things. So I thought I'd start simple today, but allow people to see if they want to do more complicated, or complex might be the right word, queries or data analytics, that they could explore lake formation or accelerated data lake.
Oh, that's excellent. So we do have one question. It's a question that comes up every time someone's speaking about AWS. It's the free trials and free credits one. So if you want to clarify that one.
So we do have a free tier on a lot of our services to get started. I'm not too sure what we're providing as part of GovHack. Do you know? Mark might know, who's a colleague. If you look under pricing for many of these services, you'll find free tier limits which talk about the things you can experiment with without running up a bill. And some of those free tier limits expire after 12 months, but some of them persist for a lot longer.
Yep, I think I've got the answer here as well for that one. So I believe that there is a Slack channel they can hackers can go to on the weekend through the GovHack Slack channel, where there will be some credits where they can ask for. So
awesome! I was hoping that was the answer.
that was what I was going to come to. Yeah, so please join the Slack channel, and myself and some of my colleagues will be there to answer your questions, particularly regarding to setting up the AWS accounts and any client credits.
Awesome. So thank you, Craig. Thank you for the demonstration. We'll now hear from Mark, who'll talk about our building scalable mobile and web applications. So welcome, Mark. You're on mute at the moment. Sorry, Mark.
Sorry, I was just waiting for Craig to stop sharing the screen so I can share my screen.
No worries, when you're ready.
So in time-honored tradition, can you see my screen?
We can, yes.
Excellent. So thanks for attending my presentation. My name's Mark Seddon, and I'm a solutions architect working with the Digital Innovation Program across Australia and New Zealand. And I'm here today to talk to you about how you can accelerate app development, particularly in the context of the hackathon, the GovHack hackathon, using a service called AWS Amplify. So in the next 30 minutes, I'm hopefully going to address 3 questions so we can all answer them. The first one is, what is AWS Amplify exactly? How can we use it to create apps more quickly? And then how can we use it to deploy our applications so we can share them? I'm going to be demonstrating the Amplify service. It's a bit of a deeper dive demo. I'm going to be showing some code and using the terminal to interact with Amplify, but I'll explain everything as I'm going along. And I'm going to be doing that through building an application. So what are we going to be building? So I've just received this email from one of our product managers asking me to create a voting application so we can see which of the serverless services is the most popular. It's a bit of short notice, but it's okay because they've already provided me with a picture of what it should look like. So this is what we're going to be building. It's going to be a fully serverless, real-time application that's going to allow us to vote on the AWS services by the end of the demo. So in terms of what it's going to look like, typically this sort of application will be developed using a single page architecture. So that is something that looks a little bit like this. We've got a JavaScript file running in the browser. It's served up via a CDN that's supplied by some kind of file. In this context, it's a CDN using a service we have called Amazon CloudFronts, and the files are served up through an S3 bucket that Craig touched on in his earlier one. And then when that JavaScript file is sitting in the browser, it's going to interact with some kind of API that's sitting in front of some kind of database. So we can all look at the services, vote on the services, and the application can interact with it. Now, that seems like it's quite a lot to do in the next 28 minutes, but I'm going to be leveraging the AWS Amplify framework to really accelerate the deployment, the creation and deployment of this application. So first question, what is the Amplify framework? So simply put, it's an integrated developer experience that has broad support for the most popular OS platforms and frameworks. So this means it seamlessly integrates with iOS, Android IDEs, and popular web frameworks like React, React Native, Ionic, and the one I'm going to be using, which is Vue.js. It provides a framework, which is an open source client framework that includes libraries that allows you to mix and match features such as authentication, data, AI/ML, or analytics to build things like onboarding flows, real-time chatbots, and much, much more. The CLI toolchain allows us to easily integrate with cloud services to create, manage, and integrate cloud services such as Amazon Cognito for authentication, AWS AppSync for the API, and Amazon DynamoDB, which is our non-relational NoSQL database service. And then finally, it provides developer tools for building, testing, deploying, and hosting the entire application with a Git-based workflow using the AWS Amplify console, simply by pointing to the code with just a few clicks. So to crack on, I'm now going to try and answer, how does the Amplify framework help us develop apps more quickly? And how can we use AWS Amplify to publish our apps? I'm going to do that through a demo. So I'm going to switch over to the browser. So this is a AWS Cloud 9 IDE, which is a cloud-based integrated development environment that lets you run, write, and debug your code with just a browser. Since it's cloud-based, you can access it from anywhere, and you can even share it with other team members in your hackathon to work and iterate on the code more quickly. So, it's a bit annoying, I've lost my mouse, there we go. So the first thing I'm going to do is I'm going to create a Vue application. So this is just using the Vue CLI tool, which I've already installed onto this application, onto the server, to deploy and create a new application. So I'm also going to switch over while that's running to this task list, which is the things I'm going to need to be able to do to deploy this application. So we're going to need a front end to deploy to the browser, an API to interact with the back end, a database to store our database logic, so our database information, some simple business logic to tie it all together, and then a real-time UI. So if I flip back to here, we can see that the applications have been created. If I switch to GovHack, it's just a simple Vue.js application. Because I'm a developer and we want to use Git-based development, I'm just going to add a repository I've already created and do an initial push-up. I'm going to use that later to deploy the application. The next thing I'm going to do is run Amplify init. I've already got the Amplify CLI, again, installed on this server. So this is going to integrate the Amplify framework or the Amplify console service with this application that I've just created. So I'm just going to call it GovHack. It's a dev environment because I'm working in dev. I can hook up a particular default editor. In this case, I haven't got one because it's a cloud-based IDE. It's already recognized that it's JavaScript, and it's already recognized that it's a Vue application, so that's pretty handy. These are just some defaults that are incorporated from the Vue application. And now what it's going to do is going to set up Amplify with the services that we need and automatically create them on our behalf. And to do that, it needs some credentials. I've already got a profile installed on this server, so I'm just going to use the default. Now, for those of you familiar with this kind of output, it's leveraging a service called AWS CloudFormation, which is our infrastructure as code service, which allows you to automate the creation and maintenance of AWS services in your account. So that's just going to go away and create them. It creates some things like IAM roles to interact with the services, a deployment bucket for the application we're going to be creating, and a few other bits and bobs. So that's it created already. So it's already suggested creating an API. Before we do that, I'm just going to say I've created the front end. So that's pretty cool. The next thing I'm going to do is, as it suggested, add an API. Now, there's a couple of different options you have here. You can either choose to create a RESTful API, which many of you may be familiar with, but you can also create a GraphQL API. So I'm going to use GraphQL for simplicity. I'm going to call it GovHack. I'm going to use an API key, again, for simplicity, but there's a couple of different other options you have. Just going to call it GovHack. Spell Gov correctly. Just going to call it 7 days for its expiry for my purposes. I'm pretty much done. I don't need any advanced settings. I don't currently have a schema. So it's going to suggest a couple, a more complex one to many, but for our purposes, it's just going to be a single object. And it's going to go away and create that. It's creating that locally in this application. I don't want to edit it right now. But what it's done is it's created a bunch of files, but this is the salient one, which is a GraphQL file. And this describes the schema for the entities that I'm going to be interested in. And this is a simple to-do entity, but I'm going to use something a bit more useful. So this is an entity called candidate, which is going to record the service that we're going to be voting on. I'll come back to that model annotation in a second, but it's got 4 simple attributes: an ID, a name, both of which are required, a description, which is not required, and then some votes they're going to use to record the number of votes that each thing has. So I'll save that. If I run Amplify status, it'll compare the local version of the repository with the Amplify console in the backend. You can see here that I'm going to push that up. And it's recognized that I've created a new API locally, and it's going to push up those changes to the Amplify console. So yes, I do want to create it. And it's asking me if I want to generate code. And that sounds pretty handy because I don't have that much time. I'm probably going to need it. So that's going to automatically generate a bunch of code for my application to use. It knows it's JavaScript. These are just some defaults that I'm going to need. And it's going to go away and it's going to create those in the backend. So if we think about what I've done here, I've just run a simple command, Amplify add API. I've defined a single entity in the console and as a GraphQL file. And then I've asked Amplify to go and create it for me. And it's already created. You can see it's creating quite a bunch of stuff there. So if I flip to the console, and the first thing I'm going to look at is AppSync. So AppSync is our managed GraphQL service. And you can see it's already created an API for us to use. So you can see here it's GovHack, the application, and then dev is the environment. If I click on that, we've got a few different pages here, but the first one is the schema. And you can see here that this is very similar to the thing I just defined in the GraphQL file. It added a couple of fields here for create that and update to that. But look at what else it's created. It's created a rich and fully featured API that's going to allow us to interact with this API. So this is quite a lot here. This is 161 lines of code that I just haven't had to write. It's automatically created it for me based on that simple schema file. So these 3 types are the salient points. So the GraphQL has 3 types of queries you can have. You can have a simple query where you get, say for this instance, it's get candidate, you pass in an ID and you get a candidate back. or you can list candidates by passing in some filter. You can run a mutation, and a mutation is just a query that changes the data in some way. So you can see it's got create, update, and delete. And this, again, is the simple CRUD applications, operations I need for developing an application, which is pretty cool. And then the final thing is the subscription. So a subscription is a special kind of operation that allows API clients to subscribe to a particular event happening, and that's going to be useful for our real-time API. Now, there's two components to a GraphQL API. The first is the schema, which defines the entities and operations for that API. And the second is the resolver, which is the thing that actually goes away and does the action of the endpoint. So if we just reload this page, because this is still running in the background, that's okay. And we look at the resolvers. We can see here that there's a resolver called candidate table for the get candidate endpoint. And if we click on that, what the resolver will do is it will translate the API call into an operation that makes sense for the data store. Now, what this has done is, because if you recall the model annotation I put on the schema, that tells Amplify that I want that entity to persist to the database. So it's gone away and it's created a DynamoDB table on my behalf. Saves me a lot of time. So the resolver uses the Apache Velocity template language to translate the call to the API into an operation the DynamoDB table understands. So you can see here it's get candidate. So I'm passing in an ID. I'm specifying a get item operation, so DynamoDB knows to get the item that's referenced by that ID. And then we'll return that as a JSON object to the API client that called the API. So that's pretty handy. The same is true for the mutations and the subscriptions and so on as well. So if I now switch to queries, drag this over, this page will allow us to interact with the API. So if I run a query, so this is a query called all candidates, which uses the list candidates API endpoint to return the items in that DynamoDB table or through the API. And I've asked it for its ID, name, description, and votes. And if we run that, unsurprisingly, we don't get anything back because the DynamoDB table is empty. We haven't populated it with anything. So if I run an insert command, what this is doing, if I just drag this over, is this creating, using the create a mutation, which is create candidate, and I'm applying 4 new objects. I'm passing in the name, in this case AWS Lambda, a description, and then setting the votes to 0. And that's going to go away and insert those entries into the DynamoDB table through the API. So you can see that's worked well. That's inserted the candidates. And if I run that query again, we can see that we get the entries back. So that's pretty handy. If I was only interested in the name and the votes, I just have to change the query, run it again, and I just get the name and the votes back, which makes it for a bit more of a flexible API than, say, your RESTful API, where you might have had to write a special endpoint to get that reduced set of results. So that's great. If I now click on the data sources, I can see here's the candidate table that Amplify has created for me. I click on that. We can see the candidates there. I can look at items, and we can see that the items have been created in DynamoDB. So that's pretty awesome. With just that line of code or that schema definition, if I flip back here and look at task list, we've created the API. We've created some front-end code for the application to use. We've created the database. So we're making really good progress. I'm just going to save where we're at. So the next thing we're going to need to do is create the custom logic. And I'm going to cheat a little bit here. I'm pulling some code. It's okay, I'll explain what I've done in a second. The first thing I've done is make a change to the schema. And I've created 3 new entities here. The first one is the new mutation called cast vote, which is going to allow our application to our users to cast a vote. And it takes in a cast vote input, which is just the ID of the candidate that we've selected. And I've also created a new subscription which is called onCastVote. And that's going to allow the API clients to subscribe to when a vote is cast, which again is going to be useful for our real-time AI UI. So the other file that I've created is the mutation. So this is the mapping, the new mapping for the API call to the DynamoDB table for the cast vote call. So if I click on backend and go to the API and then go to the resolvers, that's where I've copied it in, and I open up the mutation here. This is the translation from the API call for cast votes to the operation DynamoDB understands. So in this case, it's a update item operation. We're passing it an ID, and we're using a simple expression, which is just setting the votes field equal to the votes field plus an integer. In that case, the votes field are called votes, which is the attributes of the item in the table. And then the integer is just a simple number, which is 1. So that's just saying increment the votes for that item by 1. Close that off and run Amplify status. That should tell us that the local changes I've made will result in an update to the Amplify backend. So let's push those changes up. It's going to ask me if I want to update, which I do. It's going to ask me if I want to update the automatically generated code, which I do. And then again, that's just some defaults. So I flip back to the task list and I update that. We've got the front end, we've got the API, we've got the database, we populated that with some entries, and we've got the business logic. So we're making really good progress. The last thing we need to do is a real-time UI. I'm going to, while that's running in the background, I'm going to open up a new terminal window. I'm going to add the changes we've made, commit that, say update API. That's done. And now I'm just going to copy in some other files. So for those of you, these are just some configuration files. These are the node packages I'm going to use for the application. That's a simple config file. And then this is some styling. For those of you that know view.js, the app.view is where the magic's going to happen. So if I open up the app.view file, we can see here this is a really simple template. So for those of you familiar with JavaScript, with front single page application development, view.js or React and so on, you should find this familiar. But it's some simple HTML which asks which is our favorite AWS serverless service. And then the view magic is here. So I'm creating a button and I'm using the binding v4, which in the view.js framework means we can loop over or iterate over our local variable, in this case, candidates, which is going to be our list of candidates we retrieve from the API. It's going to loop over them and create a new button, bind the key as the candidate's ID, and then create a click action, which is going to allow us to click on it. And in that case, it's going to call the cast vote function, which passes in the candidate ID. We spit out the candidate name and the candidate votes. I'm also using chart.js to import a chart. So it's a simple bar chart. We just pass in the labels, which is the candidate names, and the number of votes, which is the votes associated with each candidate. So what we're doing, we're importing the vote chart defined in the vote chart component. Then we're importing the API and the GraphQL objects from AWS Amplify. So we've been using the Amplify CLI to interact with the Amplify backend. And then now we're using the Amplify framework, the JavaScript framework, to be incorporated into our Vue.js application to actually start integrating with the backend. So I'm pulling in the API and the GraphQL methods. We're also pulling in queries, mutations, and subscriptions. I haven't had to write them, but if I click on, say, the query, you can see here that getCandidate is equivalent to the getCandidate schema endpoint that we saw in the AppSync service, and the same with listCandidate. So this is going to let our local JavaScript application, the Vue application, interact with the backend. It's going to save us a lot of time. So what are we doing? We're setting up data, which is an empty array of candidates and some colors to make it look pretty. We set up the chart data to pass into the vote chart component, which just sets the labels, which is just the candidate names. And we pass in a data set, which again is the candidate votes associated with each candidate. But the magic really happens in these three methods, and this is about as complex as this application gets. So the first is created, and this is going to be called when the Vue.js object is created. And it uses the API object that we pulled in from the AWS Amplify framework, and it's going to call the GraphQL backend. And it's going to use the list candidates query. And this here is pretty much everything that I've had to write myself in terms of code to pull all of the candidates from the AppSync API. And then again, with methods, we've got the cast vote function that takes in a candidate ID, which creates a little vote object, which is just the ID of the candidate, and calls the API again with the cast vote mutation, passes in the vote, which is the candidate ID, to the service, which is going to go away in the background and increment the votes for that candidate accordingly. And then finally, we've got the mounted function, which uses the subscription on cast vote to register an interest into when a vote happens and when a vote is cast. And when that happens, we're going to be notified and we're going to update the UI accordingly. So that's pretty much it in terms of the development. If I close this down and let's flip back here, we can see that the API has been deployed. I'm just going to install the packages that I need. So this is installing the AWS Amplify framework. It's installing the Vue wrappers for the framework. And the chart.js application that I'm using to render the charts, and the Vue chart.js wrappers. And that's it. So if I now call run serve, this is going to run a development server for that application that's going to interact with the AWS component. So nothing's running on, no backend's running on this server, just the front end. And that's going to interact with the AWS backend that we created, hopefully. So we can see here, we've got the 4 buttons for the 4 services that we created. We've got the simple vote chart API, charts. And if I click on this, we can see the application loads up in real time. So just to show that that is working, if I look like this, go here, and drop there, we should be able to see that the application is indeed updating in real time. So that's pretty cool. That's got us a long way there, but we now need to deploy the application so you folks can see it. So let's go ahead and do that. As you know, I've been diligently updating the Git repo, which I'm just now going to push up. I'm going to flip back to the console again and browse to the Amplify console. You can see in Amplify, this is the application I've created called GovHack. And it's got a backend environment called dev, which we've just been interacting with, but there's no front-end environment. But what I can do is hook up the GitHub repository. Now, I've already authenticated my GitHub account with AWS Amplify, so it's gone away and it's registered the repositories. There's the GovHack repo that I've just created and I've just pushed up. I'm going to use a master branch. And it's looked at that repository and it's recognized that the front-end framework is Vue. It's recognized that the back-end framework is Amplify, and therefore it's going to select some defaults based off that. So we're going to deploy the updates to the back-end resources every time we commit this change. We're going to use the dev environment. This is the service role that is used to interact with the back-end environment that we created. I've already got one, so I'm just going to use that one, but you could create another one. And this is interesting. It's registered and auto-detected the build settings. So it's going to use this to build the application and deploy it on my behalf. It's just going to install the node packages and then create a distribution version of the application. Now that's good enough for my purposes, so I'm just going to go next, just check those resources and click save. And just with those couple of clicks, what this is going to do is going to go away and build this application and deploy this application on my behalf. So it's going to provision an environment. It's going to build that application, both the front end and the back end. It's going to deploy it. It's going to verify it. So this is a full CI/CD pipeline that can be used to, every time I push a change to that repo, it's going to automatically build and deploy the application. So that's a lot of complexity. I've not had to set up a Jenkins or any other kind of CI/CD pipeline. It's just automatically created it for me. That's going to take about 5 minutes. So what I'm going to do is instead flip over to the Sydney region where I've already got this application deployed. So here, this application is already deployed. You can see here it's called GovHack. I deployed it a wee while ago, and this is what it will look like when it's finished. So it's provisioned it, it's built it, it's deployed it, and it's verified it. Now, if I click on the verify, what it's gone away and done, it's actually taken screenshots of the application so I can see that it's working as expected. And then finally, just to show the speed with which you can develop, I've added a custom domain based on my personal domain, and added a subdomain for this application to be pointed at. And it's gone away and it's created a TLS certificate for that and deployed that application with a TLS certificate to a CDN called CloudFront, backed by the Amazon S3 bucket. And that just took a few clicks. So that was incredibly fast and very secure. Now, if I go to govhack.seddon.io, that will load. And then hopefully, if you folks playing along can also go to govhack.seddon.io. We can see it updating in real time. So that's pretty cool. I mean, I'm going to be hurt if people don't feel that Amplify is the best framework. But I won't cheat. I won't cheat. If people like Lambda, then people like Lambda. That's just the way it is. So hopefully, that's pretty cool. So if I flip back to my presentation and just recap, we wanted to answer 3 questions, and hopefully you can now answer these as well. So the first one was, what is AWS Amplify? And it's a set of tools and services that enable you to develop secure, scalable full-stack applications powered by AWS. How does Amplify help us create apps more quickly? You can easily set up backends for mobile and web apps with services such as authentication, storage, or APIs. And in the context of GovHack, you could bring data into DynamoDB and interact with it really quickly in your applications. And in terms of deploying your applications, you can deploy your app using a CI/CD pipeline that's automatically generated that also has feature branch support baked in, and host it on AWS with best practices for scaling, security, reliability, and global availability. Now, you might be thinking, I use pre-cooked files and snippets, but you can also think about what I didn't have to build. I didn't have to set up any servers. I didn't have to set up any databases. There were no patching or installing a Python or Node or anything like that. I simply used a cloud-based IDE and a couple of lines of code and a very simple schema. And I was able to build very quickly a real-time serverless application that we could all interact with. So thank you for your time. I hope you consider AWS Amplify for your GovHack. There's some useful links for you to go to. And again, thank you. Thank you for your time. Hopefully I piqued your interest in Amplify.
Thank you, Mark. Thanks for the tutorial on building those scalable apps on AWS. It was very impressive to see you building that up in under 30 minutes. Our hackers have 46 hours, so I can't wait to see what they can do and what they can create with all that extra time to get some X factors into the app. Starting in a couple of minutes' time, we have another session at 7 p.m. Sydney time, which is a conversation with Monash University on community safety using artificial intelligence. So thank you, Craig and Mark from Amazon Web Services.
Thank you.